Day 25 of cracking 500 AI and data science interview questions challenge. 5 questions a day, 100 days. One step closer to your dream job. If you are new here, don't forget to check out the playlist. You might have missed some key questions that will be important in cracking your next interview. I have a great shout out, guys. We have completed 24 days of powerful AI and data science learning. And today on our Silver Jubilee Day 25. Today we are going to unlock one of the most critical skills for every AI engineer, ML engineer, and data scientist model evaluation and cross validation. Because building a model is easy, trusting it is the real art. Why is model evaluation important? Model evaluation tells you how well your model performs on unseen data. It is like testing before the exam. You don't just want good marks on the practice sheet, I mean the training data set. You want to perform well in the real test. Here, the testing data set. Without evaluation, you can't tell if your model is overfitting, whereas your model might memorize the data or underfitting, which means it is not learning enough. So we have common evaluation metrics depend on the type of problem. If your problem is classification based, for that we have accuracy, precision, recall, and F1 score. If your problem is regression based, we have metrics like mean absolute error, mean squared error, root mean squared error, and R squared values. What is cross validation and why do we use it? Cross validation helps us tell model performance more reliably. Instead of training once on a single train test split, we split data into multiple folds and test each time on a different portion. Here we have K-fold cross validation as the most popular one, whereas the first step is dividing data into K parts. Model trains on k minus 1 folds and tests on the remaining, repeats this k times and averages the results. This prevents lucky or unlucky splits and gives a fair performance estimate, whereas it improves the performance of the model. What is the difference between holdout and cross validation? Holdout method is used in a way first we will split data once. 80% for training and 20% for testing, which is simple and fast, but sometimes it can give you biased results. When speed is the only thing that's important for you, then you can go for holdout method. If you want accuracy as an important thing, then choose cross validation because here it splits data into multiple folds, trains and tests multiple times, slower but more reliable. In interviews, mention that cross validation is preferred when accuracy and stability matter more than speed. How do you perform k-fold cross-validation in Python? First, let's import the required libraries. The load iris function gives us a simple data set which is perfect for testing classification models. Here, X contains the features like petal and sepal measurements, and Y contain the flower type. Next, we define our model. Logistic regression is a simple but powerful classification algorithm. We set maximum iteration as 200, so it converges properly. Now let's define k-fold cross validation. Here, n splits equal to 5, which means the data will be divided into 5 parts, each time 4 parts for training and 1 part for testing. We also shuffle the data to make the folds random and fair. Now let's evaluate the model. Cross validation score automatically trains and tests the model 5 times, once for each fold, and returns all accuracy scores. Finally, we print the scores and the average accuracy, which gives a more reliable measure of how our model performs on unseen data. What is stratified K4 cross validation? When you have imbalanced classes like 90% non-fraud and 10% fraud, normal K4 might create folds with uneven class distribution. Stratified K4 fixes this by keeping class proportions consistent across all folds. It is especially important for classification problems. This ensures your model learns equally from all classes in every fold. We have reached day 25, the silver jubilee of our journey. If you have come this far, you have already built strong foundations in pre-processing, tuning, and model building. Now it's time to become data trustworthy. Here's your day 25 dose of insight. Don't just build, validate, test, and justify your models. A model that performs consistently across folds is the one that is ready for protection.